This recording goes along with my most recent post on BeRelevant.net. You can find the link to it in the details below. But really, in that post, I'm kind of saying most of the content is going to be delivered as part of this recording, and it's really just a matter of how long is it going to take me to type everything out and for you to read the topics and the subject that I'm presenting on here versus just showing it to you. And sometimes showing it to you is faster, so that's what I'm going to do now. I'm covering GitOps, and specifically GitOps with Crossplane and Argo CD. If you're interested in this, you kind of need to know a little bit about GitOps in general. You can learn Argo CD and Crossplane. It just takes some time with each. The past few posts that I've had on my blog site were getting people up to speed with the basics and then some more intermediate subjects with regards to Crossplane. And then Argo CD has some really good tutorials as well. And I'm just running on a Kind cluster here on my local laptop. So I'm on a Mac. I've got Kind running for a Kubernetes cluster. I followed the getting started guides from Argo CD to install Argo CD. I followed the Upbound guides for installing Crossplane. And then I've set up a repo to host or to maintain my code that is going to be then synchronized into my Kubernetes cluster via Argo CD, and where Crossplane will pick that up and then go and provision things for me in the real world. And that's the base flow here. When we talk about GitOps, what we're saying is that we want our state to not only be represented by what's in a Git repository, we want it to be controlled and match what's in that repository. We don't want people to be able to change things within the cluster. We don't want them to be able to go out into the provisioned resources and change them directly. All of those latter options or operations should be blocked or remediated through a reconciliation. And that's what we'll look at a little bit here today. Now, I'm going to use Platform Ref Azure as my example here just because it's the project I started working on and recently wrapped up. And I have everything set up for provisioning to Azure Cloud right now, but this would certainly work with AWS, with GCP, DigitalOcean. List goes on. If you look at the providers that are available through the Crossplane project, it would really be the same. So let's take a look. Start off, I've probably got a bunch of restarts on here because I've rebooted my laptop quite often lately. We'll do pods. Oops. Okay, so you can see the Argo CD namespace, and it looks like, the pods are running. They're for us. Down here we've got our Crossplane pods, and they're all running correctly. So those are the two sets of pods that I'm interested in making sure are running right now. And then if I look at, do I have managed resources? I should not. I haven't provisioned anything yet, but I should have some compositions. So let's take a look for those. So here are some of those compositions that go with that project that I worked on for the Azure platform reference. We look at Argo CD, you can see I've got an application defined. This is the UI for Argo CD. You can do everything through YAML if you prefer, but the UI is actually sort of slick. I like working in it and seeing kind of the relationship between objects that get created. You'll see what I mean by that in a moment. I've set up a repo. I believe this is public facing. This is my fork. You wouldn't want to go to this one. The actual main repo is here. And so I believe this is public. Yep, it's public. If you're interested in playing with this, feel free to clone this and use it as your base starting point. I will say you can go to Crossplane and get any number of example configs for other clouds if you work in another cloud provider. But I do want to address something here, and that is it's kind of a GitOps thing, it's kind of an Argo CD thing, and it's kind of a Crossplane thing, all combined, where we work with composite resource claims in use cases where we have RBAC applied in a cluster, and the application developer, the consumer, somebody that wants to instantiate a composite resource, which is a global or cluster scoped resource. They don't have the ability to do that. So what Crossplane has done is created what's called the composite resource claim. And the composite resource claim is namespaced. So if all you have access to or privileges for are the namespaced resources, you create a composite resource claim, which then in turn, the Crossplane machinery turns into a composite resource, which then goes through a composition, which then becomes managed resources, which then become things out in your cloud provider. A little nuance of Kubernetes, a namespaced resource cannot be the owner of a cluster scoped resource. And when we look at Argo CD and GitOps in general, its responsibility is to say what's in your Git repository and then do a diff compare to what's running in your Kubernetes cluster. And if they're not the same, it starts balking about that, right? It could either delete stuff or just tell you you're out of sync and you need to fix it. Depends on how you've configured your platform. So just a native Kubernetes deployment object. When you have a deployment manifest and you place that into a Kubernetes cluster, that's going to create a replica set. It's going to create at least one pod. Those definitions for replica set and pod, those don't exist in the Git repo because they only exist once the deployment gets created in the cluster. So the way GitOps platforms address that is they look at the owner reference and the lineage between what's in the repo and what's in the cluster, and they can see that that deployment is the owner of the replica set, and the replica set's the owner of the pod, and so on. And it knows that those are supposed to be there, and it doesn't consider it out of sync, and it doesn't raise any flags. Well, with Composite Resource Claim, XRC, being namespaced and not being able to be an owner of a composite resource, that owner reference doesn't exist. So if you implement a composite resource claim to start this chain of events that creates your objects, Argo CD and other GitOps platforms get confused because they see that you have this XRC defined in your Git repository. They see that it is now represented in your cluster, but then they see a whole bunch of other objects that start getting created that they don't see the connection to. And it'll say constantly out of sync. Now, we talked about one reason XRC is important. It's if you have namespaced only privileges. There are a couple of other use cases for XRC. One other would be if resources were pre-provisioned in your cluster, you can use them to claim those pre-provisioned resources, just like or very similar to a persistent volume claim that is claiming a pre-provisioned persistent volume in the cluster. One other use case for it is when we create a object that has connection secrets or sensitive information. So a database is going to have connection endpoint information, a username, a password. The providers can write those back as Kubernetes secrets into a namespace. And when we create something beginning with a namespace object like an XRC, we can inherit that namespace into the flow and say, write that secret back to the namespace where the XRC began. So without XRC, we have to explicitly define where we want the secrets to be written to namespace-wise. So there's advantages to XRC. When I look at GitOps, and I spent some time recently really pondering this, I don't think we need XRC for a GitOps implementation. XRC is absolutely relevant and should be used for self-service when you are creating things on your own directly against the Kube API server. But in GitOps, where we're defining everything in a Git repository with approval processes, and then we're defining the application at the GitOps platform level to say this is the namespace this app goes to, this is how it's implemented, etc. All those controls and most of these things that we get from XRC are abstracted away for us by just the fact that we're using a GitOps pattern. So all that story short, I'm using Composite Resource to begin the workflow here, and if you use this repo, you'll see it starts with a composite resource, not a composite resource claim like many of our other examples are. If you use another example, you might need to tweak it a bit so that you are using or starting your flow from a composite resource versus a composite resource claim. All right, now we'll come back to this repo and we'll see how I've set it up. First, I want to show you UI here again, and I've got an application you see already defined. And as I had showed you in the console, I have compositions and everything's running in my cluster, getting ready to provision. And the reason for that is that this application deploys all the configuration for what would normally be a platform team's responsibility, defining compositions, defining composite resource definitions, XRDs, making the settings that we want to apply governance to and not allow the application developers or consumers that are going to create composite resources to change. This is another interesting intersection in between GitOps and Crossplane, because with Crossplane, we can package everything up into an OCI image. So all the compositions, XRDs, providers that are required for that set of configuration files can all be defined in an OCI compliant image and then stored in an image registry. That way, if I want to have kind of a self-service catalog or a process where I share my configs with someone else in another department, all they need to do is install that image from the registry and the cluster is completely configured for them. In GitOps, again, I think a bit of an intersection here because I don't know that that necessarily lends itself to the spirit of GitOps. So what I've done here is I kind of bypassed the install from image, and what I've done is defined everything in a Git repo and then made it an application within the GitOps platform, Argo CD in this case. And so if we look at the repo here, and you know, I've kind of shortcutted this. I've put the configs for what would be our app developer persona, and then for our platform team in the same repository. I put that down here in the notes. You know, production, these would be in two different repositories, but for now I just did it here. This WP is just a completely unrelated thing to this demonstration. But let's look at platform team. So within platform team, I've got cluster, and within cluster you can see I've got compositions. We have nested XRs and compositions, so I have my network. All this is what defines my configuration. Here I've got providers, so I know I'm going to need an Azure provider and a Helm provider. Now one thing I will also tell you is that in this setup, I've remarked out the creation of the AKS cluster, because what I want to do is I want to be able to just kind of manipulate the network sliders a little bit to convey the main of things and what we're doing. And I can't do that once the AKS cluster has been seeded onto the network. So I've just remmed it out and disabled it. I forget where I did it now. I was going to probably just in the right spot to show you. But anyways, so you know, we're only going to create network. All right. So if we come back to here, this is what's being represented through that folder in the repo I just showed you. And what's going on here, I've given this application a name and then told it to recursively go through that repository from that folder down. And you can see it's found compositions, so those are all the compositions that we have stored there. Composite resource definitions, so if you recall, we said a composite resource definition will create one or two CRDs depending on how it's configured. And then there are these cluster roles that get created by the Crossplane machinery per composite resource definition, so that we can actually use the resulting CRDs. I think the rest of those are composite resource definitions. Yep. So CRDs or XRDs in Crossplane terminology, and compositions. And we get down here, we have our Azure Provider. So Azure Provider creates all these CRDs that correspond to the things we can create in Azure Cloud. And then we have Provider Helm doing the same sort of thing. And then you can see we have some cluster roles that get tied into the providers as well, so that they have the ability to work with their managed resources. All of this is been synced from that repository into Argo CD and then synchronized into my cluster. So if I look at a composition, and this is one we'll be using, I think, mostly in this demonstration. Let's look at the network composition. I can see what's running live and what's defined in that Git repository. So in the Git repository, we can see how is this defined. And actually, I'm looking at CRD right now, I think. Composite resource definition and XRD. Yep, and that's not what I want. So let me back up. Here is what I want. I want the composition. So if we look here, the CIDR. I have that defined in the composition as 192.168.1.0/24. It implemented this composition in my cluster with that same CIDR. If I can find it, yeah, right there. If something changes now, it depends on which side it changes from. If it changes my cluster, in other words, if I go into my cluster and I change that manually, and I can show you an example of that. I will say edit composition and X network. And my API server is a little slow. There we go. Oh. See, there we go. It threw me for a loop, so I forgot I rebooted my machine without putting VS Code as my code editor in my RC file. So we'll use VI. Okay, so I just updated the composition that's running in my cluster. You can see just really quickly there, you might have to rewind the video, but it said out of sync and then synced. So I believe going from 1.0 to 2.0 already got flipped back to 1.0. And there's a little quirk in this part of the UI where even if you're hitting sync up here, it doesn't change or refresh these manifests here. So you have to kind of jump out of it and then come back into it. At least that's what I found so far. But as you see, I had just changed it to 2.0 in the cluster, and Argo CD caught that and said, nope, what's supposed to be is 1.0, and it set it back. So that's an example of we're maintaining that CIDR state within our cluster based on what's in the repository, based on Argo CD comparing it and making sure it stays the same. Now, once we enable or create a composite resource that's going to say, hey, I want to actually create one of these things, then Crossplane picks up and it starts creating those objects for us. And so we're going to need a different app for that, not this platform team sort of application, but more of an application developer sort of repo, and that's the other folder. So if we look at that other folder under AKS, I just have one simple manifest here, cluster.yaml, and these values represent what we've exposed to the persona of an app developer who would be trying to create an AKS cluster and have all the required network and whatnot created for them. They can say how many nodes they want, whether they want small, medium, or large, and then we as platform team map small, medium, large to actual VM shapes within Azure. And then since we're also using the Helm provider to install Prometheus, what version of Prometheus does that consumer want to start with? We're going to set up an application that covers this folder and therefore really just this file, but we'll see that it creates things in relation to it after we've created that XR, and that's all the Crossplane machinery. From that point, Crossplane is going to be responsible for what that CIDR value is in Azure itself. So I'll create the application, we'll deploy it, we'll see it created within Azure. I'll go into the Azure portal and then we will change it there and we'll see it get changed back there as well. And that's because Crossplane's managing that state. So now we have a closed circuit all the way from our Git repository to our actual implemented resources running in the wild. If I change it anywhere but from that Git repo with proper approval, it's always going to go back to the setting that it's supposed to be based on what's in the Git repo today. Let's look at creating an application. So we'll create an app and we'll call it Azure app because I'm feeling creative. Project. Default project is kind of a profile that you can set in Argo CD, and it defines sort of how this particular application is treated with some base properties that you can configure. I'll just go with default for now. Sync policy I'm going to leave to manual because if I set it to automatic right now, you'll kind of miss a few things that I want to show you. Repository, I need to tell it where we're getting stuff from. So this is the link we need. And then since I am using different folders, the path or the folder within that repo that I'm going to. And then I'm going to say target cluster is the one Argo CD is currently running in. Now, I'm not creating any namespace resources, so if you don't define namespace here, Argo CD will just go to default namespace. It doesn't really matter in this case because there are no namespace resources that will get made out of this application. So we'll just leave it blank. Okay, so let's create it. Okay, now we have our new application. It's out of sync because it's set to manual and we haven't synced it yet. And you can see it sees just that one object, X cluster, which exists in our repo. So that is reading that right from here, kind X cluster, and that's what we see. Once I synchronize this, it's actually going to create this object in the cluster, and then Crossplane is going to see that composite resource created and start doing the things that it's wired to compositions and providers to do. So let's take a look at that. We'll just manually sync it. And it starts to build out. So you see the relationship now here that was picked up on through Argo CD, looking at the owner references coming down from that object that it knows is supposed to be in the repo itself, X cluster. And then that composite resource created a link into compositions, which created some managed resources, which are then being picked up by the provider and being provisioned into Azure. So if we go look at Azure right now, we will see the resource group that has been created, the network, and the subnet. And you see it's 1.0. Now, we tried to change it to 2.0 inside the cluster, and Argo CD prevented us from doing that. Let's try to change it within Azure Portal and see what happens now. Okay, so we saved it. It's now 2.0, just like we did in the cluster. But as soon as Crossplane reconciles this, it's going to go back to 1.0. Okay, so now you see it's gone back to 1.0 based on the reconcile loop in the Crossplane machinery. If we really truly wanted to change this to 2.0, the only place we can do it is through our Git repo. Now, the right thing to do here would be to go to my fork, and I guess I can show you that. So let's just look at the slightly longer way, the right way. I'll go to my fork of that primary repo. Okay, so we'll go to Platform, Cluster, Network, Composition, and we can see we're at 1.0. This is where we can change it. So I will click on Commit Changes. We'll come up top. See that we can open a PR for this. And I won't be too descriptive of what I'm doing. Now, reviews required, merging is blocked. Because I'm an admin in both of these repositories, I'm going to go ahead and be able to approve it myself. Again, not what you want in the real world, but I will do it here. Okay, so now that's updated the main repo, which is what's feeding into Argo CD. And if we come down and look at our composition, let's see if it's already synced or not. Desired manifest is still there, so let's sync this object. And the automatic syncing on Argo CD is something I haven't completely figured out how to tune yet. So, and if you recall, I almost forget it every time. I have to leave this screen and then go back in for that to update. Let's see. No, not yet. So I will do brute force sync. We should see that it thinks it's out of date. Yep, so now it realizes it was out of sync, and now it looks like it's synchronized. So let's look now at our desired state, and it's still saying 1.0. Interesting. Sync again, Argo. Okay, now it caught the network. So that is hopefully, no, very interesting. The world of demos. Okay, so let's see if we can figure out what's going on here. First, let's do a sanity check on the repo itself. And make sure that I did commit and merge that change. Oh, wrong side. Okay, so it is in my repo. Let's come out here. Now we can get some message information here. Occasionally it's helpful. I found it to be helpful very often. I don't see anything that's balking here. Let's come back. I'll try to sync it again. When in doubt, sync again, I guess is Argo CD rule of thumb. Okay, so I'm out of sync. Let's synchronize again to get back in sync. And let's look at our network composition. And there we go. Okay, so eventually we got to what we were expecting. I don't know if this is Argo CD or if it's me. It's probably a little bit of a combination of both right now. But anyways, we got there. Let's see what's running in the cluster. Did Argo CD pass that through to the cluster? It looks like it did. So if we come to our Azure portal, we would expect it, Crossplane, to have brought it to here. And there you have it. So that's a run through of GitOps using Crossplane and Argo CD, showing where the control points and gates are and how it creates kind of a closed circuit all the way from your Git repo to your live in the wild running resource.